John, thanks for coming back on again. Really
Sure.
appreciated your slideshow that you showed us the other day, and really eager to dive deep into some discussion. Just to bring everyone back up to speed, I am talking here with John Bachmann, who was with the EPA for 33 years and is a rock star with all things related to air quality. So. We're going to do a little question and answer related to air related issues and his work with the EPA. Thanks
Okay.
for being here.
Sure.
So my first question for you is um, related to geographic location and maybe suburbs versus cities. Are there places that, because of geography, have a more challenging time dealing with air pollution, and or are suburbs and cities having a difference of how they are, what type of air exposure that they might be dealing with?
All right. It turns out to be a complicated answer, complicated question, complicated answers. The answer is yes and yes to basically the two implicit questions. One is, are there places that are more prone to having high levels of pollution? Absolutely. As noted, I think I said it a few times, that Southern California, and in fact the Central Valley of California, has a unique meteorology that helps trap air pollution. So they've got an ocean, and then they've got some mountains, and they have between the two, if the sea breeze is pushing things in, and you hit the mountain, and then there's an inversion that happens, and so you get a lid on things. You have the capacity to make. It's why photochemical smog was discovered in all the world. It was discovered in Los Angeles because that was the best place to make it. And it's harder to meet a standard there, and there tends to be higher exposures. There's just no question about it. There are places in the eastern United States in the summertime, lazy, hazy, crazy days of summer. Why is it hazy? It's hazy because air masses slow down. We've got a high pressure system. Things are moving slowly. And if you're unlucky and you don't have a rainstorm, that ozone builds during the day, mixing with, you've got, this is all over the area. This is like hydrocarbons from the trees mixing with the NOx, and it happens over a big scale, and it travels on down. If you're lucky, like Washington often has rainstorms, and the rainstorms kill the peak ozone later in the day. So if you're lucky, or if you have a particular place that's prone to those kinds of events, then you might have better air pollution. And in some years, you get more rain than others. With particulate matter, any kind of condition that causes an inversion or causes the air movement to slow down, less wind, makes more air pollution. Any place that has more wind in general, like Florida, has less problems in some respects because they're a peninsula with lots of sea going both ways. They can still have some pollution, but it's not. It's not. If Florida was in the middle of the eastern United States, it'd be way worse. It's the meteorology drives. In fact, where you live, where I grew up in Norfolk, and I can prove that by how I just said the name of the city. But but at any rate, we have more of that contribution. Is why you don't have as much snow, right? You got the water there, so it's somewhat better meteorology. Apparently, Phoenix has some real issues with making. They're having an average this summer, July. They had an average temperature of 93 degrees. That's day and night put together. They go up to 120. They go up to ridiculous levels. But they've had some issues with dust storms. So it's dry, dusty. Boom, the dust storm comes in. That's sort of natural dust, but it's contributed to a particle problem that comes from other sources as well. So yes, meteorology can change things. Houston's got a particular problem because the wind will blow out to sea and during the day, and then it turns back and comes back in. So they're downwind of themselves, which is a problem. So there's different scales. But the other scale to think about that you ask about is, what about cities, suburbs, and where you live? And that does make a big difference. You can put up a slide here for me, and I'm going to show you different scales to worry about. The first one we're going to talk about, though, most all, is a personal and near roadways. There are studies that show that people who happen to live near roadways tend to have higher mortality rates, but higher levels of sickness, respiratory related, sometimes cardiovascular illnesses. And we're not 100% sure about some of that, but we're certain that vehicles have something to do with it. But also, if you happen to live in a more industrialized area, areas with, like Gary, Indiana. I did my master's thesis in Gary, Indiana, and a lot of people live, right near those big steel mills and some of the other things, petroleum refiners and whatever. And there's a tendency, just like with Superfund sites, that guess who tends to live closer to those heavily traveled roads, who lives near dumps, who lives near these big sources. They tend to be people who are poorer, and often that means, especially in urban areas, it's going to be African Americans. If you're in some places of the country, Hispanics, and so there is an environmental justice aspect to this this kind of thing. But also, no matter who you are in fact, if you live near a roadway, you have a higher exposure to some things, or if you live near some particular strong source. And one of the reasons that doing something about diesel emissions is really good in that case is reducing the levels of particulate matter for everybody that lives in the area. It's a really good thing. Now, here's what's weird. Ozone's totally different with respect to that. Ozone affects the suburbs more. Why? Well, why is that? Because it turns out the cities have high concentrations of vehicles that put out nitrogen oxides. And so even though you may have, if you haven't reduced the amount of ozone coming into an area, if it comes in from long-range transport, and you'll see on the slide I show you, you can see there's a regional transport kind of zone here, the eastern United States. There was some of that. I mentioned some of that in the other talk. So ozone comes in. When it hits the city, the nitrogen oxides titrate it, just like acid-base titration. It titrates it. The NO from the cars turns into NO2 and eats up the ozone. So ozone levels in the middle of New York City are lower than they are downwind in Connecticut. Okay, so people in the suburbs are getting higher levels of ozone, where the people living in the cities are getting higher levels of particulate matter. Both are bad, and they're getting it from regional and local sources as well. And in fact, you can see the difference in trees that live in Central Park and some trees down further in Long Island of the same kind that have more damage to them. Okay, because the ozone levels damage trees. Well, some of them do better in the middle of a city. Well, who knew? I mean, it's because and planting trees, by the way, in cities is a great thing because it helps soak up ozone and PM and other things. So it's a lot of people are pushing that, and it's a good thing. It also causes things to be cooler. Another good thing. So anyway, yeah, it does make a huge difference. In the chart, you'll see this very localized kind of exposure, personal exposure, near roads. Maybe you live with a smoker, or you live in a place with some other kind of outdoor source. Then you have the urban scale, and on the urban scale, you have this kind of higher level of PM, lower level of ozone potential. And then as you get to the eastern United States, you get a different results, or Southern California as a region, you get to different results, or Houston as a region. And then if you get global, you'll find that there's kind of a background of ozone going around everywhere, that everybody's getting exposed to. And acid rain, fine particles, nutrient loadings, about eutrophication there. A substantial part of the eutrophication in Chesapeake Bay is coming from the air, from ammonia and from nitrogen oxides that fall out and fertilize, basically. So, and it falls out in the watershed, not just on Chesapeake Bay. It falls in the watershed, rolls in. So air pollution on a regional scale and a global scale has impacts that vary with what's the problem I'm looking at. And this slide kind of shows you the kinds of pollutants that tend to be bigger in personal, local, regional, global. And global is where climate change absolutely is.
Wow. Wow. Powerful points. Um, it was really interesting to me to hear you talk about the potential equity disparity that pollution can bring, and how by targeting diesel, we could potentially reduce some of that equity disparity. And just very interesting to hear how ozone affects the suburbs and how maybe dendrochronology studies can point out how tree growth and different pollutants are affecting places. Really, really powerful stuff. Thank you for such an in-depth
You just
answer to that.
used a word that means tree epidemiology. I think that's pretty cool.
Yes, indeed. Indeed, and that's something that we do in our
Tree
class. We do
rings, and yeah, if they know about it
exactly
already, if
tree
they know
tree
about it
coring.
already, I'm impressed. I'm impressed.
Absolutely. Oh yeah, we
All
go
right,
out
cool,
and
cool,
and do it. Yeah, we do it. We
cool.
do tree ring studies. So to move on to another question, I'm interested in how the 6 criteria air pollutions were selected, and why carbon monoxide was sort of lumped into that, but carbon dioxide wasn't.
Right.
Um, and if I could just throw another quick twist into this, um, it was so powerful when you were talking in your last point about some natural pollutants. And, I mean, we breathe out carbon dioxide, but, trees put out particulate matter and VOCs. So it was just interesting for me to hear, as we think about defining pollution, that natural things can also be a pollutant and that maybe concentrations have to play a role in that. But at any rate, 6 criteria air pollutants, and why carbon dioxide wasn't a part of that.
Right. Well, first of all, the original 6 criteria pollutants are a little different than the ones we have now, just by one pollutant. Um, they came, first of all, the whole concept was let's measure things we know about that's out there and that we know how to measure and so forth, and that come from sources and so forth. And the Public Health Service had come up with, based on measurements they had been taking and on, the science up to that point. We're not talking about the middle of the 1960s. And the 1967 Clean Air Act amendments, one of the good things they did is they caused this whole concept of criteria pollutants to be developed. And the idea was, let's look at pollutants that are common all over the United States, and they come not just from a single source, because if it comes from a single source, you can just do that source and be done with it. But if it comes from a lot of different sources and mixes in and it varies, the amount varies in one city versus another, then it's ripe for the kind of air quality management schemes that they were envisioning. But to make them work, they needed to define what's safe, what are we shooting for, what's clean air, okay? And so at the time they had 6 pollutants, and the 6 pollutants were particulate matter, which at the time were measured mostly by this total particles vacuum cleaner on a filter kind of thing without regard to size, and sulfur dioxide, nitrogen oxides. Things from combustion were always going to be on the list, and those are big emissions from combustions that we know cause health effects. Carbon monoxide, did I mention that already? Yes, for sure, that has to be in there. That's the 5th one. 6th one turned out to be hydrocarbons. Hydrocarbons is kind of like particulate matter. Now think about the difference between particulate matter and hydrocarbons versus carbon dioxide, nitrogen oxides, and so forth. 3 of them or 4 of them you can write a chemical formula for and say that's what it is, sulfur oxides, there may be more than one, but there's not many, But particulate matter, what's in there? A lot of stuff. Hydrocarbons, even more stuff. Well, why rewrite, and we knew particles cause health effects, but we were less sure about, as a group, whether hydrocarbons cause health effects. So instead of making a criteria in terms of what the health effects would be from generic hydrocarbons, many of which are harmless, like methane, breathing it, unless you get too much, just you're asphyxiated, it just doesn't do anything. So they decided they would regulate hydrocarbons that made ozone. So the original concept was 6 pollutants. We didn't have any others. We could have added benzene, could have added carbon dioxide, I suppose. But back then, climate wasn't exactly number one on the hit parade. It was this air pollution I can see that's hitting me in the face and causing sickness and people sick and everything else. And there weren't really debates so much going on about climate. There were people aware of it, and people aware of it since the late 1800s that it could be an issue. And there was certainly discussion about it during the first Earth Day, but it didn't have the cachet, all right, at the time to decide. I mean, it doesn't cause health effects directly, first of all. It causes them indirectly. So it just wasn't in anybody's consciousness. It wasn't in their front page. We weren't measuring it, you know, other than
Right.
Ronald Lowell maybe. But at any rate, so it wasn't then, okay? And then as time went on, when we first started to review the standards after setting them in 1971, they were finalized in 1971, and reviewing the science and deciding that ozone, you know, maybe at that time had to be made weaker, carbon monoxide stayed the same, sulfur dioxide stayed the same. We ended up doing something about particulate matter later, but when it came to hydrocarbons, we're going, the only reason we have this thing is to help meet the ozone standard, and it turns out the science we based that on came mostly from Los Angeles, and it doesn't apply in a lot of other places. It didn't make any sense, and we couldn't concoct there weren't generic health studies about hydrocarbons versus health effects, so they did away with the hydrocarbon standard. In the meantime, EPA got sued by the National Resources Defense Council, saying that, well, yeah, we know we were getting rid of the main source of lead with all this catalytic converter stuff and taking lead out of gasoline, but we think you ought to have a national ambient air quality standard because it comes from a lot of places and so forth, and they won the case, so EPA set a lead standard, and we still have a lead standard.
Wow.
So that's why the sixth pollutant switched from hydrocarbon to lead, and one of the reasons that there weren't a bunch of others added, you might have thought about benzene, which is coming from a lot of sources and a lot of different places, but it requires this intense activity of monitoring and other things, and in many cases, some of the more toxic pollutants come from limited numbers of sources. You can regulate its sources directly, and later under the Clean Air Act amendments in 1990, we figured out ways to add the risk to the decision making, not just the direct effects. So there was a high hurdle to add any new criteria pollutants. It wasn't as hard to change the metrics. It wasn't as hard to say, hey, let's have two different kind of particle standards. Let's have a standard for particles less than 10 micrometers and particles less than 2.5. So we have two standards for one criteria pollutant. So we were able to do that. We did the first part of that in 1987. We added PM10, got rid of TSP. TSP was short for total particles that I talked about earlier in the earlier discussion. And then in 1997, as you saw from the picture, that's when we finally set the first fine particle standard and really put them together. They still are regulating mixtures of a lot of stuff. And there's a certain power in multi-pollutant monitoring, and let the devil sort out which ones are bad here, because a lot of them are, and we have a lot of evidence relating the mass of this stuff to health effects. And that evidence, by the way, as I pointed out last time, has gotten only stronger with time. So that's why that. So, okay, we start to learn more about climate, and we're starting to think about climate. And what about the Clean Air Act being used to do something about CO2? Because you saw in that chart, that progress chart, I say that CO2 kept going up. The things we worked on got better. The things we didn't work on didn't get better. Shock. So we were sued. EPA. We not at EPA anymore, but EPA was sued in the 2000s to consider regulating carbon dioxide under the Clean Air Act. That didn't mean criteria pollutant necessarily, but just regulate it at all. Should you do it? And that turned into quite an interesting thing. It went up. I think the administration fought it at the time. The Bush administration, I think, fought doing it, but they certainly looked at it, and it went to the Supreme Court. Supreme Court ruled that yes, if EPA finds that that carbon dioxide contributes to adverse effects on public health or welfare, if they can make that conclusion, then in fact they can regulate CO2 under the Clean Air Act. Didn't say how, just can do. So that caused a hard look by EPA that moved over in 2009 to a new administration, and they looked at it and they came up with a finding of whether or not they believe that this pollutant does have adverse effects on public health or welfare, and it does, even though the effects on health are indirect. I mean, if you die from overheat or you get burned in a fire or drown in a flood, that's an indirect effect of climate, and therefore there's an effect on public health, and there's clearly an effect on public welfare, and therefore EPA concluded yes, we can regulate. So then a whole new set of analyses got done. We could look at, well, what should it comes from all kinds of sources, it's everywhere. What if we set a national neighborhood air quality standard? Well, let's make it a criteria pollutant. And they actually analyzed whether that made a lot of sense. I would say that one of the problems is that, as everybody knows, the levels of carbon dioxide in the United States are only partly of its own making. We make a huge contribution to the global background of carbon dioxide, and you can see that from the Mauna Loa stuff, or where, how many parts per million we are of CO2. But you could zero out all the carbon in the United States and still potentially violate a level that might be adverse because the rest of the world hasn't done it. That puts you into a strange situation. Plus, it turns out that that whole, let's monitor carefully and that sort of thing. So there's some basis for thinking about it, but there's also some basis for saying, what if we regulated the emissions from power plants and cars, which are two of the biggest sources of CO2, just go after them directly with standards? And that's what EPA and in that administration decided to do. They came out with early standards for improved gas mileage, but they actually had a greenhouse gas standard that regulated CO2 and whatever else directly, and it's mainly CO2 in this case. But then they also came out with something called a Clean Power Plan that would cause power plants to reduce the amount of coal they burned in general, so they could switch to gas or some other things that would be cleaner and promote cleaner energy, that sort of thing. So that considers costs, so it's not ultimate. But EPA ended up regulating, trying to regulate both vehicles and power plants with respect to CO2, and they also added some rules for methane. Now, most of those rules have been rolled back, not all of them, but most of those rules have already been rolled back after the current administration pulled this out, or announced they were going to pull us out of the Paris Climate Agreement. But I think still there would be that most of the people that are looking at what should we do about climate aren't looking at using the Clean Air Act's peculiar version of air quality management as the best way to do it. You'd really want to go after the system of electrical generation, which, by the way, has to grow if you're going to have electric cars, which is one way you can get reduced emissions of CO2 from cars. So the idea being that, is it the best way to do it? Probably not. And the plans that have been put forward by most people, I think almost none of them ever include that as a major approach. I think, in other words, I think the decision not to do it made sense. But the decision to do nothing makes no sense.
Right. An interesting point to think about in terms of regulation. What is the best foot forward, and what science and policies, how they work together to solve a real world problem. You spoke well to the complicated nature of trying to create those standards. John, could you speak to me a little bit about what creates a secondary pollutant like tropospheric ozone?
Sure. And it's funny because the Clean Air Act uses primary and secondary for different reasons, but primary pollutants, to remind everybody, are the ones that are emitted directly, and they stay that way. Most pollutants change a bit. And secondary pollutants are ones that are formed in the atmosphere from what we call precursor pollutants. So let's take ozone, which is the quintessential example, and other photochemical oxidants. You take a volatile organic chemical. Some of them are just pure hydrocarbons. When you say volatile organic chemical, it might have a nitrogen or an oxygen on it, but whatever. Like, ever smell, if you ever fill the lawnmower, you smell that stuff, that's hydrocarbons, and it's volatile because that's why you smell it. The same thing is coming out of trees, by the way. And some people who have allergies, it's really not. It really tends to be more from little particles than it tends to be from the gases. But trees and other things are emitting these things as well, these volatile organic chemicals. So they go up in the atmosphere, and they will react with nitrogen oxides in the presence of sunlight in a pretty complicated little reaction set. And depending on how much of each there is, you'll make some ozone. And if you crank in a little more, if you're in the middle of a forest and you crank some more nitrogen oxides, you get more ozone. If you're in the middle of a city and you add more nitrogen oxides in a place like Los Angeles, you'll get more ozone. But if the ozone came from somewhere else, well, maybe not. It depends. In other words, it all depends. Bottom line, sunlight, stagnant conditions, chemical mixtures, and now you're playing with the O2 in the atmosphere, and you're throwing out a free radical, and the free radical turns the O2 into O3, and the O3 is reactive, and it wants to find something to hit. If it sees an NO atom, it'll go away. It'll disappear. If it doesn't, and it sees your lung next, it's going to hit your lung, and maybe it'll cause an effect. And those are secondary pollutants. The same thing's true for some particles. Acid sulfate particles, ammonium sulfate, sulfuric acid, form in the atmosphere from sulfur dioxide. So they come out and they turn into this other stuff. Other particles come out like black smoke, black carbon, diesel, comes straight out as that stuff. It pretty much stays the same. It might get a little more toxic, might react to things, a little bit of secondary, but there are things that directly emitted that come out just bad right away, and the others come out as gases, which by themselves might be bad. SO2 is not great to breathe either, but it turns out it looks like it gets worse as it reacts and forms some of these secondary pollutants. So that's and it forms a mixture. And we're not sure exactly how these acid sulfates work. They cause biogenic things to make particles, amazingly, in the summertime. They also make metals more soluble, so that the particles that have metals might leach out the metals in a way that make them more available to cause more effects. So there's a pretty complex mixture, and we don't understand all of it, but we know that as a group, this stuff tends to be bad. So secondary particles are a huge part of the two biggest air pollution problems that we have in the United States, and those are ozone and photochemical oxidants that go with, and fine particles.
John, I really appreciated your answer for two reasons. One, your explanation and examples that you provided for O3 and the reactions were wonderful. But I also liked that you said that we don't know or fully understand everything with what's going on there. I think a lot of students feel like everything's already been studied, everything's already been written about, and how can they, as a young person coming into the world, make change and be a part of this bigger picture, and do as what you did, which was get involved and work towards making real substantial change to the environment, to human health, to make the world a better place. Which sort of brings me to a point that might relate to how can these students that are watching this video, do you have advice for them to have them that they might want to pursue the same career channel that you pursued, or are thinking about what they might be wanting to go to school for, or they might not even know what air quality jobs look like, but they know they care about the environment and they want to make a difference. what might they be, what should they be thinking about, or what recommendations might you want to toss out there to them to put them on the right path?
Well, there are so many possibilities. I will say that in terms of where you go with it, there's a science path, and you can turn into a researcher. And that study I showed that just came out in late June from the Harvard people, I can't think of anybody that's done any more to help the cause
Sure.
of worrying about air pollution than those people who have done those kinds of studies. Incredibly important. So a science route that can take you into academia can lead to tremendous things. And it helps if people who fund research in the federal government and in state government recognize that that's an important thing to study and do. So
Right.
that happens, but recently some of that money has gone away and people are trying to put it back. So that's still an important thing. So that's one path. Another path is, gee, I want to regulate. I want to do something. I want to be involved. You can be involved at a local agency level. You can become an engineer and work on that kind of stuff. Monitoring, you can get into monitoring, that sort of thing. You can work at a state agency who actually does the same kind of things, and you can work at EPA, which is the federal version of all this. But there's the Park Service and the Forest Service. There's programs on the environment in a whole lot of federal agencies. So it depends on where you want to work outside and work in the trees. Yeah. You want to get into climate. Um, there's some you know there's some jobs for people who may or may not want to get heavy into science, but really are good with their hands and know stuff. There's a whole lot of things that can be done on energy conservation, things that can be done on people have got to put up solar and put up wind and those kinds of renewable energies and do those things, and it's almost a trade kind of thing. You can a person that wants to work with their hands, that wants to do that, just thinks that's cool, but I want to do something about the environment. You can work for industry. You can work for a consultant firm. You can work. There is a lot of possibilities out there, and you've got to kind of decide who are you. How do you want to do it? Or maybe you just one of the things I think is so great about courses like you teach, that even if you decide you didn't want to go into the field itself, you're a better citizen because and you know when people are telling you things that look right and are consistent with facts and things that aren't. And that's being a better citizen's part of it as well, and making your own personal choices. But I think in the end, people, the collective people, doing their own personal choices isn't going to be enough. It's going to have to be, programs that make it possible for people to be their best selves and do these kinds of projects, whether they're on using their hands, whether they're doing the science, whether they're monitoring, whether they're doing accountability to see if things are working or enforcing. There's legal aspects of this. You can be a lawyer. Environmental lawyers, hugely important, obviously. So a lot of ways you can go.
Thank you. I know my students will appreciate that perspective. So, I think it's on everyone's mind. How do you move forward with following your passions and wanting to be an impactful citizen? So, appreciate that.
It's funny. I have been a windsurfer and a body surfer for a long time growing up. I go to Virginia Beach for that sort of Croatan and stuff. Got to do it in Hawaii once. And the whole concept to me of being in that transition zone, that you feel like I'm in water, I'm in air, I'm in land, I'm at that interface, was the career I ended up doing. And I used to have my title, you may not remember, is science and policy. So I would explain science. I would know enough science to explain it to policymakers in a way they could understand. That's an important thing. Not every scientist can do that. But I can't claim I'm fully a scientist. Also, it's equally important to explain to scientists that, hey, studying this methyl ethyl chicken wire over here isn't where the real issues look like this to us. And, in 5 years, we'd like to know more about X, Y, and Z. So communicating the policy needs to science, what you need know more about to do something, turns out to be a valuable thing. So I worked between those two worlds, lived most of my time down here in Research Triangle Park, working in a policy office that's right next to the largest concentration of environmental research in the world. That happens to be Research Triangle Park. That includes the universities around here, the National Institute of Environmental Health Sciences, the EPA, and then there's some other industry folks that are around that are doing research in the area, and consultants and that sort of thing. So this is a hotbed of that, and I just couldn't have been happier with the with the with the choice, how I ended up in this magical spot doing both things. And I will tell you that that somebody put a sign in French on my desk, and I'll just give you the translation. In the country of the blind, the one-eyed man is king. And so I could walk into a policy office, and I knew more science than they did, etc.
Right. Oh, that's so interesting. I like that you use the analogy of two worlds, and finding that sort of that space in between. I think that's where a lot of interesting work happens in between, two separate fields, and there's that white noise that hasn't been filled in yet. So that's exciting. I think for students to think about, that might have multiple interests on how they can bridge a divide, to make the world a better place as well. So thank you for adding that. I'm curious, in this world of COVID-19 that we're living right now, there's been a lot of news articles about pictures of animals, walking in places that normally they're not, and and some of this may be concocted or false, with all of a sudden rivers and looking cleaner than usual. But you spoke a little bit about how historically our economy is tied to pollutants, and I was wondering if you could maybe relate a little bit of that to these current circumstances that we're
Yeah,
in.
but for sure, we decoupled the economy in a large way from those charts I showed you from air pollution. Air pollution went down, the economy got better, but there's still a relationship. So you remember I pointed out when we had a little recession and people drove a little bit less, we had a little bit of better air quality during that time, and a little bit less CO2, for example, at that time. And in the early stages of this, in California, they noticed it to a lesser extent, but they noticed, gee, it's cleaner than it's looked in a long time here. Now, it's gotten worse again, and as people went back to work and things got worse, but in places like New Delhi, India, you can see things that they haven't seen before. I mean, they have the worst air pollution in the world there. That's the worst air pollution in the world, literally. And it's particles from all over the place. And they had these pristine days that they haven't seen. What's good about that? China, same thing. You can see maps where things got better. So the Chinese had the same experience when they did the Olympics, and they shut things down on purpose to make it look better. And everybody said, hey, that's the way it ought to be. And so people started to demand more. And so there's going to be a demand. But if you look at it the flip side, well, good, this is good for climate. No, not particularly. It doesn't do that much. It doesn't stick necessarily, and you still are going to have to face that fact that it's happening. We are not doing that much about climate by even the recession/depression kind of conditions we have now. While we have to focus on these things, there is just no question that there are cases where in these places, and monkeys have taken over in places in some foreign countries that they didn't before. People weren't running around. People come back, they'll be gone again. So I mean, it's temporary. So it's an interesting thing. I will say the other thing is that there is clearly, when you look at what COVID goes after, it goes after the heart, goes after the lungs, goes after all kinds of things, and it goes after the same things that some air pollutants, like particulate matter, have been associated with. So there is little doubt that either COVID creates more people sensitive to air pollution, or that, in fact, some people who get COVID are more likely to have worse problems if they have been exposed or being susceptible to COVID if they've been exposed to air pollution for a long time. It just seems highly likely. There's a little bit of science on this. It's not at all conclusive yet, but the bottom line is just makes sense that there's a relationship there. Either way is bad. This is not. This is bad. This is, obviously a bad thing.
Boy, that's a potential correlation that I had not thought of yet. The idea that lung and heart problems from COVID will make more of society susceptible to bad
That's right.
air.
That's right.
Wow.
That's certainly the case.
Um, Geez, that's a powerful statement that I hadn't even
And
begun
there's
to think about.
there's a race relationship in who's having those more serious effects. I mean, this is a
Mm,
fraction of all the people who get some kind of a long-term thing, but
mm,
enough of them do to make it. I mean,
that equity
it
piece,
hasn't we
right?
haven't stopped yet. We don't know how big it's going to be, but it's significant. We have millions and millions of people already susceptible, so it's not like we're looking for more here, but
Right.
it certainly can happen.
Mm, wow. Um, uh, Maybe on a similar front, um, as we think about how to improve from here and how we move forward, um, I keep thinking about sacrifice. And does environmental change to improve air quality, um, should it be geared towards just the idea of we need to make more sacrifices in our lives? Um, or is there or is that too narrow a scope in terms of thinking about how to approach controlling a problem?
Yeah, I think it's too narrow, obviously. I certainly, let's put it this way. I don't feel, I don't feel like today, other than the fact we're in the middle of a pandemic, let's just set that aside. But that 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 what I have access today, I happen to drive a plug-in hybrid, so I get gas 2 or 3 times a year. I don't go and I therefore emit less air pollution and less carbon dioxide. That car works every bit as good as any other car I've ever had, except I don't have to do as much maintenance. Um, and I've got these unbelievable tools that we're all using now in terms of computers and other things. All kinds of things are better than they were in the 1960s. I wouldn't trade places to be back in the crap in Detroit that I was in with where I am right now. Or even if I had to be in Detroit, it would be better to be there now than in some respects than 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 it was back then. So is it a sacrifice? Did we really sacrifice terribly? If you look at the economy, it kept getting better, and in fact, air pollution control creates jobs. I mean, there are people losing jobs for this thing, but more people lost jobs in the coal industry because they decided to go to big machines and do stripping coal out of the ground instead of deep coal mining, which was a horrible job, by the way. But the reason the miners are out of work is partly that, and partly now that there's enough fracking, people switch to gas, and so a lot of these things are happening anyway. People are losing jobs because of of global economic conditions and all kinds of other reasons, and more automation. So you can lose jobs a lot of ways. This is one that happens to create something good that goes with it, and in fact, and sometimes creates more jobs. I mentioned a bunch of classes of jobs that we'll need to have if we're actually going to have to take on climate. So yeah, it all depends on what's the thing that makes you the happiest. I mean, there's going to be an issue before it's all over. I mean, I don't think people have to completely give up meat, but it would be nice if people ate less meat, because it's hard now, at least, to see how you get rid of all the methane you need to get rid of. So there's going to be some things that will be different. You can have more electricity and cleaner electricity than we've ever had before. More total electricity produced. You can still have TVs, computers, all these other things, just that you won't be emitting carbon anymore. And that's why a lot of companies like Apple and others are going to totally solar powered cloud services. Because if you don't go to solar powered or renewable energy supply for that, it is worse. It is something you'd have to give up, but you don't have to. There's so much you can do by electrifying and doing a lot of other things that it doesn't necessarily mean that. Where we live, how we live, is it are you better off to have a car if you live in New York City, or are you better off, I mean, the one thing that worries me a little bit is that what does COVID do to people? Do people 5 years from now still worry to ride in the subways? People are starting to worry less about it now, but that if you don't have to have a car in New York City, you save a boatload of money, and you can get an Uber if you need a car, or you can rent a car if you need to take a trip. So do you have to own one? So you want to live in the suburbs? That's a different lifestyle and that sort of thing. So you probably do need a car, but you can get one still. So I could see there being a better, healthier world, certainly than it would have been. I mean, if we don't do these things, it will definitely be worse. You want to see a really, in the long run, in the lifespan of your students here and their kids and their kids' kids and their grandkids, they're going to see either a transformation that brings things to better, far better than they would have been, or a disaster. I mean, we're talking about hellscape type stuff before it's all over in the long, long run. Now, when, how often, how long is it going to be before Antarctica melts, and we end up, we end up, 200 years, 300 years, whatever. Some of this is long, long term. Some of this is happening 2040. You're not going to be able to hang out outside in the summertime in Phoenix and in India and some other places. There's some really great stuff you can look up on the web now. If you look at the New York Times, some of those forecasts of where it's going to be too hot to live at some points. I mean, whoever thought of that? You can't live here in the summer. You can't work outside in parts of India, Africa, not so much the United States, although there'll be pockets like Phoenix where there'll be times when you can't. But it's consider the alternative. I'll put it that way. But I
Right.
don't think we're all running around in sackcloth and ashes. We don't get to have movies anymore, or video games, or other stuff that's fun. And gosh, there's a lot of fun stuff to do outside.
Right.
Example, boogie boards.
Understood. Understood. Virginia Beach is ripe for that, no doubt about it. Um, so I think that's the bulk of the questions
Okay.
that I had for you. I really appreciate the time and was just thrilled to hear your perspective, and I'm sure my students will have just a lot to digest with your thoughts and enthusiasm, and I really appreciate
Okay.
your perspective and wealth of knowledge coming into this. Is there anything before we go that you want to throw out?
Nothing to add. I hope you'll show at the end of this, or either the end of the other one, show those half century of progress reports that we put out. We've updated them. They look really nice this year. There's even a teacher's guide, and I'll tell you that your current teacher, when he was at another school at Kellum, actually worked with students and developed a lesson plan that is now in that teacher's guide that other teachers around the country can use. And we have some lesson plans from some other APES teachers as well. So I do want to mention that. I also want to say, having participated in some of the work you did there, judging one of those competitions you had among your students, I just admire your skill at teaching. He's got an award, folks, if you don't know it, from EPA for his teaching in 2016. And he is a master teacher. You guys are lucky to have him.
Well, thank you, thank
All
you.
right.
This was a great opportunity. Really appreciate it.
Okay. Take care.